Very warm good morning, everyone. Today we are going to study about electric current, and also we will study about electromotive force and potential difference. Let us try to understand what is electric current. Okay, suppose there is one cell has a positive terminal at one end and negative terminal on the other end. When we join these two terminals like this and we keep here one resistance, suppose we have kept here one bulb, one fan, or one any electrical instrument we are keeping in this circuit, and we are connecting this negative terminal and positive terminal by the help of this wire. Then what happens, this negative terminal consists of large number of electron. That electron will try to move and reach the positive terminal. Okay, when this electron will flow here in this circuit, the rate of flow of charge the rate of flow of charge is simply known as current. Suppose we are finding the value of current over here, then per second how much charge is moving from this circuit, that gives the value of current. We can also write like this: current that is denoted by I is equal to charge divided by time. Charge can be denoted at Q and time by T. Simply, current is equal to charge per unit time. Anywhere if we have to measure the current, suppose we are measuring the current value in this circuit over at this point, then in 1 second how much value of charge is moving here in 1 second, that gives the value of current at this point. So current, which is represented by I, can be written as charge divided by time, and the unit of current is ampere. Okay, the unit of charge is coulomb, and we know that the unit of time is second. Suppose we have to find the value of 1 ampere current, then 1 ampere current is equal to 1 coulomb of charge divided by 1 second. Simply we can define this 1 ampere current like this: in 1 second, if 1 coulomb charge is flowing through this point, suppose in 1 second 1 coulomb charge is flowing through this point, then here the value of current is 1 ampere. If 1 coulomb charge is moving per second at any point, then the value of current at that point is 1 ampere. This 1 coulomb charge means we can also think practically like this: 1 coulomb of charge means 6.24 into 10 to the power 18 electron. If from any point, suppose at this point, in 1 second 6.24 into 10 to the power 8, if this much value of electron is moving from this point in 1 second, then that gives us idea the value of current over this point is 1 ampere. I hope you are understanding. The movement of current, the movement of charge per unit time gives us the value of current. 1 ampere current means 1 coulomb charge divided by 1 second. If from any point 1 coulomb charge is moving in 1 second, then the value of current is 1 ampere. We can also say like this: 1 coulomb is equal to this much value of electron. If 6.24 into 10 power 18 electron, this much electron is moving from any point in 1 second, it means the value of current is there how many? 1 ampere. I hope you have understood this. A lot of numerical can be asked related to this. Sometime question can be given to you. If 0.5 coulomb charge is moving from any point in 2 second, find the value of current. Then we know that current formula is current is equal to charge by time. Charge by time. It means 0.5 coulomb charge divided by 2 second. It means how much, calculate it, whatever the value will come, that is the value of current, we can find out. I hope you are understanding. The coulomb of charge is given, time is given, simply divide this charge by this time, we get the value of current. Okay, now we are going to understand uh, electromotive force and electromotive force and potential difference. Electromotive force and potential difference. Let us develop the concept for this. This electromotive force also it is regarded as EMF, potential difference. It is also regarded as PD. Suppose take one cell here. Let us try to understand what is electromotive force. This side positive charges are here and negative charges are here, like this. If we connect uh, this negative and positive terminal by any wire, by keeping one resistance here, resistance, we can keep here any electrical instrument like bulb or anything, then this electron will move like this and want to reach this positive terminal. Then how does this electron moves? This cell provides some energy to these charges. The cell provide some energy to the charge so that it can move from one end to another end, or one terminal to another terminal. Then the energy supplied by the cell per coulomb of charge, we can say 1 coulomb of charge. Suppose uh, this cell is supplying x joule of energy to 1 coulomb of charge, then this x is the value of EMF of this cell. How much energy the cell is supplying to 1 coulomb charge to move from one terminal to another terminal? The energy supplied by the cell to 1 coulomb, that is called electromotive force. Okay, and let us understand potential difference. When that charge move over here, 1 coulomb of charge, how much this charge is doing our work? It means they are converting this electrical energy into non-electrical energy. Suppose we have kept here bulb, then how much heat energy and light energy is produced by 1 coulomb of charge? That gives the value of potential difference. We can summarize like this: energy supplied to 1 coulomb charge to move from one terminal to another terminal, that is called EMF of that cell. And when that 1 coulomb charge is moving in the circuit, how much work is done by this 1 coulomb charge when it moves from one terminal to another terminal? That work done is called potential difference. I hope you are understanding. Energy supplied, that is called EMF. Work done, that is called potential difference. Okay, and we have to uh, uh, consider this for 1 coulomb charge. This electromotive force is always greater than potential difference. Its value is greater, its value is slightly less. Because how much energy is supplied here, that much work is not done. Some of the energy is lost due to some uh, internal resistance that is present in the cell. How much energy is provided, that much 100% work is not done. So energy value is more, work done value is less. So we say EMF is always greater and potential difference is always smaller. Okay, this both are measured in volt. Okay, both unit is volt, volt, volt. uh, Apart from this, when we have to measure the value of electromotive force, we have to measure in open circuit. Okay, if this circuit is open, we have to apply here one voltmeter and we have to measure in open circuit. If current is not flowing through this wire, then we measure the value of electromotive force. We can say EMF is measured in open circuit. But if we have to measure the value of potential difference, in similar way, here voltmeter is connected, but this circuit is closed, switch is on, current is flowing here. At that time, we measure the value of potential difference. Okay, we can say this is measured in closed circuit. I hope we have understood the differences, clear-cut differences between the electromotive force and potential difference. More in other video. If still you have problem regarding this, please comment. But like my video, subscribe my channel. Thank you very much. Best of luck.